I want to explain something that is slightly complicated. Not very complicated, but to some extent. So the redox reaction, gaining and losing an electron. So you have a molecule, So when one molecule gaining an electron right here, right? So that's called a reduction reaction, right? Reduction. When molecule loses an electron, that's called an oxidation reaction. Oxidation reaction. So I can reduce this molecule by giving, right? So reduction gain of electron, and oxidation is a loss of an electron. So I can reduce this molecule, and this molecule will gain an electron. And I can oxidize this molecule, and this molecule loses an electron. So altogether, this reaction is called a redox reaction. Reduction, oxidation. So this constantly happens in our system, in our body, reduction, oxidation. Not necessarily oxidation is bad, or the reduction is good or bad. So this is just an electrons being moved from one place to another. What you see here on the board, it's an ionic reaction. So the electron is being transferred from one element to another element. So what happens when one gains an electron, it becomes more negative. More negative. When one loses an electron, it becomes more positive. Why is it so? In this example of sodium and chloride, so let's say sodium has 11 protons and has 11 electrons, right? Sodium loses an electron. So 11 protons and 11 electrons. So now it's 11 minus 1 electron. Now it equals 10 electrons. So it has more protons. If it has more protons, it is considered more positive. Chloride has 17 protons, so it has 17 electrons. Chloride gains an electron. Now 17 electrons plus 1 electron equal 18 electrons. So we just accepted one extra electron, so now it becomes more negative. We used to have 17 electrons, now with 18 electrons. If we would gain 2 electrons, it would be 2 negative. Calcium, for example. Calcium plus 2, so the calcium lost 2 electrons. Lost from where? When you look on the periodic table, all of the elements are neutral. So the calcium atomic weight, and that's the number at the bottom, is 40. And atomic number is 20. So atomic number represents the amount of protons. And if it's a neutral, and all of the elements on periodic table are neutrals, so the amount of protons must equal the number of electrons. So that becomes electrically neutral, right? Positive and negative attract one another. So the proton and electron attracts one another. So it also has 20 electrons. So, but in chemical reactions, what happens that calcium loses 2 electrons. So now it's 18 electrons. So it's more positive. That's why we show calcium with 2+. It's just an example on calcium. So let's use the classic example with carbon. How do you calculate how many neutrons, protons, or electrons? Again, on periodic table, carbon, atomic weight is 12, atomic number is 6. Atomic number represents the amount of protons. So in the carbon, number of protons equals 6. Protons on a neutral element will always equal to the number of electrons. So the number of electrons also 6. So protons are positive, electrons are negative. Within the nucleus of an atom, we have neutrons and we have protons, and we have electrons orbiting the atom. Protons are positive, electrons are negative. They attract one another. That's why it's hard for the electron to escape. But neutrons are neutral. So here we can only see information of protons, atomic number, and atomic weight, 12. To calculate how many neutrons, all you have to do, take 12, atomic weight, and subtract the number of protons, 6. 12 minus 6 equals 6. So there's also 6 neutrons. It just happened that way that it equals. So, but if you take an isotope, for example, of carbon, isotope of carbon is 14. So atomic weight for the carbon is 14. But atomic number for the carbon is still 6. So how do you calculate the amount of neutrons? The amount of electrons still 6, right? Electrons 6. Protons are 6. But the neutrons, all you have to do is just take atomic weight, subtract atomic number. Atomic weight is 14 minus atomic number is 6. Amount of neutrons here is 8. So the neutrons are 8, but electrons 6 and protons are 6. So I hope that I did not complicate the stuff.